Hi there. Today we're going to talk about dilations. And that's a transformation that makes a figure big or small. And we can make these figures big or small by multiplying the figure by a scale factor n, okay? And we're going to get an enlargement, and that's when the figure gets big if my value for n is larger than 1. Okay, we're going to get a reduction, meaning that the figure gets smaller if my scale factor n is between 0 and 1, okay, a fraction. And as a result, when you do a dilation on a figure, you get something that's called similar figures. And what this means is that you have the same shape but different size. And so I like to think of like a toy car and an actual car, okay? Those are similar figures, all right? One is they're the same shape, they're just different sizes, okay? I like to also think of like a globe, all right? And then Earth, okay? They're the same shape, they're just different sizes. Now, some properties of similar figures means that the angles are congruent. Angles are congruent, and that the sides are proportional. Now, proportional means that we have equal fractions, okay? And we'll talk more about that in further sections, but I want to use all of this information here, okay, talking about how it's a transformation that makes a figure big or small. We can make a figure bigger by having a scale factor larger than 1, a reduction by having a scale factor between 0 and 1, and as a result, we get similar figures, same shape but different size. Angles are congruent and the sides are proportional. Let's look at an example. Okay, so in this picture here, I have this statement here that says triangle ABC is similar, okay, just this symbol here means that they're similar to triangle DEF. Now, when I have this statement here, A corresponds with D, all right, B corresponds with E, and C corresponds with F. And you can see that here in this picture, okay, that A and D correspond, B and E correspond, and C and F, all right? So you can often tell by the picture, but you often really want to use the way that this is written to show you what corresponds to what, all right? And what we want to figure out is the scale factor here, okay? And notice that we have a right triangle here of lengths 3, 4, and 5. And over here, we also have a right triangle of lengths 6, 8, and 10. These figures are similar. They're the same shape, they're different sizes. And what I did was I took all of these side lengths, multiplied it by a scale factor to get my new side lengths, okay? Therefore, these are similar. What I want to do is figure out the scale factor, okay? And by doing that, you can think intuitively about this, okay? What I can do is I can take 3, multiply it by what number to give me 6, and that's going to give me 2, okay? So 3 times 2 gives me 6. 4 times 2 gives me 8. 5 times 2 gives me 10, okay? And I'm just thinking intuitively. Now, if you wanted to figure this out, what you could do is you could use the variable n, okay? That's what we use for scale factor. And you can set up various equations, and you could say 4 times some number gives me 8. You can say 3 times some number gives me 6. You can say that 5 times some number gives me 10. Okay, and if I solve each of these equations, I get that n is equal to 2. Divide by 3 on both sides here, I get that n is equal to 2. Divide by 5 on both sides here, and I get that n is equal to 2. Okay, so every time I do this, I get 2, all right? Now, another way to do this is to think about what you have here, okay? Triangle ABC is your pre-image, all right, your OG, and then DEF is your image, all right? If you take the side lengths of your image, okay, and you divide by the side lengths of your pre-image, all right, that will also give you your scale factor n, all right? So if I were to take, say, the side lengths of 8 and divide it by its corresponding side length, which is 4, all right, and take the side length of 6, divide it by its corresponding side length of 3, okay, and taking the side length of 10, dividing by its corresponding side length of 5, all right, all of those things are going to give you the same value of 2, okay, which is your scale factor, all right? And so that's one way that you can do that. Now, what I'm also showing you here is that these sides are proportional. Remember that we said proportional was that fractions are equal. 8 divided by 4 is equivalent to 6 divided by 3, which is also equivalent to 10 divided by 5, okay? Now let's look at another example. Okay, so let's say that I want to dilate this segment AB about point P, all right? First of all, we have this rule here, all right, that I'm going to dilate about point P of by scale factor n, okay? So the D represents that you're going to dilate. The first letter here is the point at which you're dilating about, and then n is your scale factor, okay? So we know that we're dilating about point P, but we don't know our scale factor. So let's say that we have this. All right, let's say that we take segment AB, we dilate it about point P, and we get segment A prime, B prime, okay? So what we want to figure out from this picture is our scale factor, okay? Now here's what I know, that the length between points P and A is 2, and the length between A and A prime is 6. Well, if I wanted to set up an equation to solve for this, what I would do is I would write the length of PA times your scale factor n gives you the length from P to A prime. Now, what I want to do is figure out what these lengths are. The length of PA is simply just 2. So I have 2 times my scale factor n gives me the length from point P to A prime. So point P to A prime, the length from here to here, 2 plus 6, is a total length of 8. All right, so from this, I can solve this equation for n by dividing both sides by 2, and I get that n is a scale factor of 4. All right, so the rule that I would write here would be that we're dilating about point P by a scale factor of 4. Okay. Now, one thing to note is that because my scale factor is larger than 1, notice how my original line segment was small and it got bigger as we dilated it, okay? Let's look at another example. Okay, now in this example, what we want to do is we want to find the scale factor n, okay? And what we have is I have this length xy, and we dilate it by a scale factor and it gets smaller and we get a length of x prime, y prime, okay? And what we want to figure out is, well, what's the scale factor? And what I can do is I can set up this equation and do Rx times my scale factor n gives me Rx prime, okay? And so this is the same equation that I did in the previous one, and I write this equation every single time that I'm trying to solve this, okay? Now the length from R to X is a length from 1, add 4, that's going to be a total length of 5, okay? So 5 times some number, that gives me Rx prime, and that length is 1. All right, so what I want to do now is solve this equation for n. I can divide both sides by 5, all right? 5's divide out, and I get that n is equal to 1/5. Now 1/5, that's a fraction. 5 doesn't go into 1, so I just leave it like that, okay? The decimal value of this would be 0.2. Now notice that this is a number that's smaller than 1 and greater than 0. It's in between 0 and 1. And what happened was we got a reduction, okay? So depending on what your scale factor is and what your picture looks like, you can tell what kind of number you're going to get depending on, you know, what you're going to get for your scale factor, okay? So that's all I got for this video. Hope you enjoyed it. We'll talk to you soon. Thanks. Bye.